Bismillahirrahmanirrahim. In this session, we will provide the solution of the topical question paper part 5. The topic is DC circuits and we will solve here 7 questions. The course is Cambridge O level physics and the course code is 5054. Question number 1. A cell is connected in series with an ammeter and a lamp. The current is 1 ampere. In which circuit, using identical cells, lamps and ammeters, is the current reading 2 ampere? In circuit configuration A, two cells are connected in parallel, but the terminal voltage is the same as that of a single cell because the configuration is parallel configuration. So the amount of current that ammeter will measure in option A is still 1 ampere. In option B, two cells are connected in series configuration, so the amount of voltage available to this circuit is doubled. But as the lamp is also doubled, so the resistance also becomes twice. So the current in this configuration is 1 ampere. In option C, two lamps are connected to the one cell, and that's why the resistance is twice and the current will become half, 0.5 ampere. In option D, two lamps are connected in parallel, so the effective resistance has become 1 half and the amount of current will become double. 1 ampere will flow through the upper lamp and 1 ampere will flow through the lower lamp, and the ammeter will record 1 plus 1 is equal to 2 ampere. So option D is the correct option. Which circuit contains a cell, a light emitting diode and a fixed resistor? So you can see a light emitting diode and a fixed resistor in option A. Question number 3. The diagram shows a cell connected in series with an ammeter and 3 resistors, 10 ohm, 20 ohm, 30 ohm. The circuit can be completed by a movable contact M. When M is connected to X, the ammeter reads 0.6 ampere. What is the ammeter reading when M is connected to Y? At X, the ammeter reading is 0.6 ampere and the resistance is 10 ohm. So the voltage is IR 10 multiplied with 0.6, it is 6 volt. Okay, and when contact M is connected with Y, the resistance is 30 ohm. Voltage is still the same, 6 volt. So I in this case will be V over R, 6 over 30, that is 0.2 ampere. So option B. So you can see the solution. At X, I is equal to 0.6 ampere, R is equal to 10 ohm, so V is equal to 6 volt. And at Y, voltage is 6 volt, R is equal to 10 plus 20 is equal to 30 ohm, and I is equal to 0.2 amperes. Question number 4. In the circuit shown, at which point is the current the smallest? The smallest current will flow through the 6 ohm in the parallel configuration, because in parallel configuration the total current will divide itself and the lesser amount of current will flow through the branch which offers the highest resistance. So it is B, option B. The current is same at point A and D and is the full current being supplied by the battery. This full current will be divided into two parallel branches as shown, and the smallest current will flow through a branch of the highest resistance. So the smallest current will flow through the 6 ohm resistor branch, and that branch is accessible through point B. So point B is the correct option. Question number 5. An electrical engineer connects a diode to a radio so that if the battery is connected the right way around the radio works, and if the battery is connected the wrong way there is no current. So which diagram is correct? It is diagram A. It is the correct diagram. The current will flow. It is forward biased. In B diagram the current will not flow. It is reverse biased. And in C diagram it is short circuiting the whole battery, and D is also a kind of short circuit. So option A, forward biased. In forward biased condition the current will flow. So option A is the correct option. Question number 6. Diagram 1 shows a resistor connected to a battery, an ammeter and a voltmeter. The ammeter reading is 0.5 ampere and the voltmeter reading is 3 ampere. A second identical resistor is now connected in parallel with the first resistor as shown in diagram 2. What are the ammeter and voltmeter readings in the circuit shown in diagram 2? The voltmeter reading will not change, whereas the ammeter reading will become double because the resistance have become one half, because two identical resistors are connected in parallel configuration in diagram 2. So the potential difference remains the same in parallel configuration, so the voltmeter reading will not change and will continue to show 3 volt. If two identical resistors are connected in parallel, then their effective resistance will become one half, and as a result the total current being provided by the battery will become twice, and the ammeter will measure 1 ampere. So option D. Okay, question number 7, the last question for this session. A thermistor is connected in a circuit with a 6 volt cell, a 3000 ohm resistor and a voltmeter. As shown, the graph shows how the resistance of the thermistor varies with temperature. What is the temperature of the thermistor when the voltmeter reads 2 volt? If you see, the two resistors are connected in series configuration, and 6 volt is input voltage is available across them. So there is a voltage divider rule concept is being applied here in series circuit. 2 volt is dropped across thermistor, it is the given. So voltage drop across 3000 ohm will be 6 volt, total volt minus 2 volt, that is equal to 4 volt. Now the main concept, as the thermistor voltage 2 volt is one half of 4 volt, and that 4 volt is available to 3000 ohm resistor. So in this voltage divider circuit, the thermistor resistance should also be one half of 3000. As the thermistor voltage is one half of the voltage of the 3000 ohm resistor, so the uh, thermistor resistance should also be one half of the 3000 ohm resistor. This is the main concept. So the thermistor resistance is the 3000 by 2 is equal to 15 ohm, 1500 ohm. Okay, so again, thermistor voltage is half the voltage of the resistor. So in the circuit diagram you can see the thermistor voltage is 2 volt and the voltage is twice across the 3000 ohm. So similarly, if the voltage is half across the thermistor, then thermistor resistance should also be half, and that is 3000 divided by 2. So it is 1500 ohm. And from the graph you can see that the 1500 ohm meets 60 degrees Celsius temperature. Okay, so you can see from the graph that 1500 ohm thermistor resistance is when the temperature when the operating temperature is 60 degrees Celsius. So option C.